Hello, everyone, and welcome back to Manufacturing Mavericks, a YouTube series where we talk with product experts about different types of equipment that's available to you in the manufacturing world to help your production, quality, and everything improve. Today we have on Jon Bruner with Lumafield. They have a CT scanner that is incredible. I remember the first time I saw it at the trade show, or actually no, it was at our Pigskin Kickoff at Kratz and Saunders in North Carolina. I was amazed with the technology, and I'm really excited for everybody listening to hear more about how this scanner works. So, Jon, I'm going to hand it over to you. Why don't you introduce yourself, what you do at Lumafield, and talk to us about how Lumafield got started?
Great. Thanks so much, Shae. It's really great to be here. My name is Jon Bruner. I'm head of marketing at Lumafield. Lumafield was founded in 2019, and our goal is to make industrial CT accessible and ubiquitous. So, industrial CT scanning has been around for a few decades, but it's always been a very expensive and exotic technology that costs, half a million to upwards of several $1 million. You only see it in the very, very biggest companies. And even then, when a company has it, they often have only one or two CT scanners, and they're only accessible by sort of going through a technician who's sitting there and operating it all day long. So it doesn't wind up being a first line tool for design engineers and manufacturing engineers. And we see it as something that can be an everyday frontline tool for engineers.
I think
So we've
that's
developed,
very unique.
go ahead.
Sorry, go ahead, keep going.
So we've developed a platform that includes a couple of different CT scanners and a cloud software platform that makes it inexpensive, accessible, easy to use, and easy to share with collaborators so that CT can be kind of an investigative tool and a quality control tool for entire teams as they develop products and bring them into production.
And where did the CT scanner originally, even the expensive versions, what industries do you guys typically find those in?
Yeah, traditionally you'll find CT scanners in aerospace. That's really the industry that has adopted CT scanning most widely. They'll do things like CT scan turbine blades for jet engines, critical castings, metal 3D printed parts, things where you need to find porosity or look for other internal defects on extremely high value products. You
Okay,
also find it in like the medical device industry.
okay, yeah, I was gonna say that one. Now, with the way that you guys have things, excuse me, the way that you guys have things set up, what other industries do you guys see the CT scanning capabilities moving into?
Yeah, so we're really excited to bring CT into industries where legacy CT systems haven't made sense before from a cost perspective. So that's more in the direction of consumer products, consumer packaged goods. We have a lot of customers who are inspecting plastic packaging. They're looking for leaks. They're looking for thread engagement issues. They're looking for integrity problems in, in injection molded plastics. We have a lot of customers in the athletic equipment industry, including a number of shoe manufacturers. So something that's common across both of those industries is those are industries where engineers are accustomed to just cutting things in half, to section them and look inside. If you have a leaky shampoo bottle, often what you do is you immerse it in epoxy resin, you cure it overnight, and then you cut it open with a bandsaw and you look at the section real close. Same with shoes. If you're a shoe designer in the US and you have an overseas factory manufacture your shoe, you'll get back an initial run of 50 or 100 pairs, and you sit there with a bandsaw and cut them down the center to section them so that you can see how your contract manufacturer has produced them. And in both cases, in both of those applications, our customers are now using industrial CT to do that sectioning. So they're able to see their products in a lot more detail. They're able to do it non-destructively, so they can section, any number of times on the same product. And they're able to do a lot of analysis that you can't do by just cutting something open with a saw.
That is so interesting. I never thought about shoes. And you're right, shampoo
Yeah,
bottles, even just like water bottles, like what is the cup now? Everybody likes Stanley's. Like
yeah,
everybody's
the
got a
Stanley
Stanley or
quenchers.
something. Like even those, oh my gosh, I didn't even think about that. Well,
Right.
that was a great introduction. I think everybody is now like, okay, can I see this thing? So I know you have it behind you. Do you want to kind of
Yeah,
through the
absolutely.
Yeah, go ahead.
Yeah, I'm in our office here in San Francisco. We're headquartered in Cambridge, Massachusetts. We have an office in San Francisco where we do a lot of our software and marketing work, and then we have customer experience centers across the country in Texas, Florida, Minnesota, and Michigan. So this is our Neptune industrial CT scanner. So I mentioned earlier we offer two different CT scanners. The Neptune is kind of our lab model. It's what you would find in a product development group. It's great for running fast one-off scans and looking at things in detail. We also offer a scanner that we call Triton that's more for production use cases. It can go online or line adjacent. But this is the Neptune scanner, and the way that it works, industrial CT is similar to medical CT. The idea is you're taking X-ray images from different angles and then using software to reconstruct them into a 3D model that you can analyze. And in a medical CT scanner, the machine looks like a donut basically, and the patient lies inside it, and an X-ray source and an X-ray detector rotate around you, and they take those X-ray images from different angles of your brain or a joint or something. In the case of medical CT, same principle, but the machine is configured differently. So rather than the X-ray source and detector rotating, we rotate the part inside the machine. So over here, this is our X-ray source. It's coming out through this window. It's projecting a beam of X-rays through a thing that we're scanning. In this case, it's a plastic soda bottle. And on the other side of the object here, we have the X-ray detector, the scintillator it's called, over here. So when we project a beam of X-rays through the scan subject, it casts a shadow on the X-ray detector, kind of the familiar black and white X-ray image that you will have seen, at the doctor's office and so on. And we rotate the part inside the machine so that we're able to scan it from different angles. So I can show you what that looks like.
Yeah, while you
Now,
pull up those images, quick question. So I know
mhm.
we talked about like you had said like a shoe size, or in there you have like a Coke bottle. You also brought up things in aerospace. I know sometimes those parts can get bigger with the different CT scanners. How big of a part or an object can you put inside the scanner?
Yeah, that's a great question. We can scan objects up to about the size of a basketball. So the scan volume is a cylinder, but with our expanded scanning process that sort of like runs a scan at an offset, we can scan larger objects. So you can scan things like a full size, men's shoe, um, up to about that size.
Very cool. While you're pulling this up, I do have another question. I noticed that Coke bottle has liquid in it. Can you
Yeah,
scan it with the liquid in it?
yeah, you can. It's no problem to have liquid in it. Water, which is the main ingredient in Coke, does attenuate X-rays, so it'll look darker, and you'll be able to distinguish it. The way that I scanned this, however, uh, was just the cap assembly and the neck, so I don't think we'll see any water in it here as we go through. Um, but I can show you kind of what this looks like. These are what we call the radiographs. So these are the original two-dimensional X-ray images that we're capturing as we go along. So we're rotating the Coke bottle inside the machine, and then our software takes this collection of two-dimensional images and it reconstructs them into a 3D model that you can now kind of like explore in a number of ways. So you can crop in and out and sort of like see how the whole thing fits together. Look at the thread engagement. There we go. Here's a view with some thread engagement that we can see. So you can see the two materials here. Um, Industrial CT can distinguish between different materials by density. So in the case of this Coke bottle, the bottle itself is made from a denser plastic than the cap. And so they're color coded for density, and you're able to see kind of to distinguish the materials from each other in a view like this. So this is the 3D model, but we can also look at it the way that a physician would look at a human CT scan, which is kind of like scrubbing through slices like this. You asked about liquid. this is a droplet of Coke that's it's trapped in the top of the cap.
My mind is blown right now just watching this.
Isn't it fun? And this is,
Yes.
it's not just fun. It's if you're a packaging, engineer at this bottling plant, and these bottles are leaking, that is a crisis, and you have to figure out exactly what's going on. The old way of doing things, by taking a Coke bottle and putting it in resin and then cutting it in half, you get one shot at trying it. You have to cut in exactly the right place, um, and you're likely to disrupt the product by cutting it. You're likely to cause all sorts of other effects that'll show up in your analysis. So this
Right.
way you get this like incredible full view of it.
Right. And you would be wasting product, right? I mean, if they have to cut it,
Yeah,
they're technically, I mean, they'd be wasting product. Even if they made a perfect one, they'd have to test it, scrap it, and then know that it's good, right?
yeah, exactly. And you find it at a lot of manufacturers, you do kind of a sampled destructive testing approach for quality. You might take your first five articles off the line at the beginning of a shift and section them on the spot, and then discard them, and that becomes waste. And then you might take like every hundredth or every thousandth object off the line and section that as well as you go through the day. So we have a lot of customers who are using even this, our Neptune, our kind of like lab scanner, um, in situations like that where they have it like next to their line. It's on the factory floor. They're taking one in 100 or one in 1,000 products off the line. They do a quick scan. They confirm that it has none of their known defects, and then they're able to sell that product. It's a saleable product, and it's not just going to waste.
That's great. And how fast, because I'd imagine cutting the product, putting it in the what did you call it? It goes inside the
Like an epoxy, a resin or
epoxy.
something.
Yeah.
Yeah, yeah.
Um, that probably takes a lot more time than just putting the bottle in the CT scanner, letting it scan it.
Yeah, and it's very labor intensive. Someone who's like potting a product and sectioning it is actually standing there doing it, whereas you can sort of throw an object in the CT scanner in a matter of a few seconds. You asked kind of how long a scan takes as well, and that varies depending on the materials that you're working with. So for lightweight plastics like this, scan can be as fast as a few seconds, especially if you know exactly what you're looking for in the way of defects. And then scan can take as long as overnight if you want to create a really spectacular, high quality scan that of a very very dense object where you want to sort of be able to explore it in depth.
Makes sense. And now, how do these scans get back to the software? I think I was previously told that it's on the cloud, right? I know you mentioned that a little bit earlier. So, is it instantaneous, right? When the scan goes, it sends it to the cloud, sends it to the software? How does that work?
Yeah, yeah. So as you scan the radiographs, those two-dimensional X-ray images are being uploaded to the cloud, and then the reconstruction happens on the cloud. And you can see here, I'm showing you these scans from a web browser. So you can open scans anywhere in the world. You can share them. It's just like having a Google Doc or a Microsoft Office 365 Word document. You share it instantaneously and securely with any collaborators who need to see it. So it's entirely cloud based and web browser based.
And so anybody on a quality team can open this. You can have up to 20 people on a quality team all looking at this at the same time in a secure
Yeah,
way. It's all you need is Safari and being able to have the software on there.
yeah, that's exactly right. And that's a big difference compared to legacy CT systems. The way that you would receive a CT scan if you work for one of these companies that has an older CT scanner um, is you don't actually get access to the scan itself. What you get back is like a PDF report that's composed by the technician who operates the scanner. Because those older systems have a giant PC that's attached to the scanner and like one software license to run the reconstruction software on the PC next to the scanner. And so the technician who's running the scans takes the reconstructed scan, looks at it, takes some screenshots, puts them in a PDF, and sends the PDF to you as the engineer who commissioned the scan. So this is a much more hands-on way of using an analysis tool. It's like night and day.
Hands on, and I'm also thinking as you're saying this, one eye on something, on a report, on looking at a particular product or a defect or trying to find something, you're less likely to find something than if you're sharing this with four or five people in your quality team that are all looking at the same thing. You're
Yeah.
probably more likely to reduce errors that could occur versus if one person was doing it. And with that, do does the system itself, does it pick up defects? Like I know in like a standard like vision system um, that we would sell,
Yeah.
it could pick up defects because you would upload a CAD file and it would know and it would say, oh, here's a little red spot. Now, does this software do that
Mhm.
as well?
Yeah, that is a great question. We can do it in a handful of different ways, but uh, the basic answer is yes. So I'll show you a couple of different examples of this. One is this is a die cast alternator housing. So here again, these are the original 2D radiographs that the machine takes, and then this is the reconstruction. So this is the 3D model. So castings like this develop a lot of porosity inside um, as the metal cools, it develops these little bubbles inside, just like you'd find in an ice cube. And that porosity is a major structural challenge and something that engineers have to consider very carefully and design around and anticipate. We're able to run automated porosity analysis. So I can show you. Um, this is a look at the. Let's see. So this is a look at the pores, the little voids inside this casting that our software automatically detected. So you kick off a porosity analysis, and we can go look for these pores. And we'll even give you a table, like a readout table here, um, where we say kind of like what's the minimum and maximum pore size, the mean pore size median, the number of pores altogether. Um, and you can set a threshold. So you can say, I'm concerned with pores that are, bigger than this amount or smaller than this amount, and just see those. So this is one type of automated analysis we can do. We can also do, CAD comparisons and scan to scan comparisons. And so this is, to your point, you're describing sort of a CAD comparison where you can take a CAD file and then take your ground truth object and compare the two and see where they deviate. This is a running cleat that we scanned both before and after it was worn, and then used our scan to scan comparison tools to show kind of where the wear happened. It lost material in this area, and it started to sort of bulge out over here just above the sole.
That is fascinating. I can't believe it picks it up just like that. Now, you said that you can do like you can compare the CAD, but if there is no CAD, like on the first example you showed, it just
Mhm.
knows to pick up that like the porosity based on the metric that you put in. Like I'm looking for holes this size or things that size, and it just automatically picks it up.
Yeah, exactly. You kind of like set your acceptance criteria and set a threshold for pores that you want to detect, and then it finds pores. We can also find cracks. We can find inclusions where maybe you're using a powder-based process or some other process that's very sensitive to foreign contaminants getting in. We can identify if your inputs have been mixed or if there's some contaminant in your part as well.
Fascinating. Now, are there any other examples that you have that you were wanting to bring up and kind of show?
So another big application that we've discovered is in batteries. So lithium-ion batteries, in particular, they're powering the next generation of electronics. They're going into electric vehicles, but they can be very dangerous. And if there's a manufacturing defect that causes them to short circuit, then they can explode spontaneously, and it's a big problem. You saw this with the Samsung Galaxy Note a decade ago. Just about every EV manufacturer has had an issue at one point or another with battery defects. Um, so industrial CT lets us evaluate batteries very, very effectively. This is a CT scan of a cylindrical lithium-ion battery. Um, and we're able to to crop in and look at it internally in a way that you would never be able to with destructive testing, because again, you can't cut into these batteries safely. That'll cause an explosion as well. So here you can inspect individual layers inside the battery. You can ensure that the separators and the tabs are intact, um, and you can just sort of generally uh, ensure that you're not experiencing any of the kinds of manufacturing defects that cause explosions and fires. So you can see it in enormous detail. You can take dimensions and ensure that you're meeting your requirements. Um, Check out every tiny feature. So this is one of the production scale applications that we've been going into. With We can scan batteries at pretty high volumes, like those that you would find in some EV plants and other kinds of manufacturing lines.
Wow. And actually, with the battery thing, I have a story for you. I have a stimulator device implanted in my spine, and those have batteries in them.
Hmm.
So, like, if like an
Oh wow!
industrial scanner or something, like if they didn't use that to pick it up, like that would be the only way. So they would have to use that to make sure it doesn't leak like inside of me, or otherwise I would die. I would probably die. So I mean,
Right, right, right.
that is incredible. Even knowing that, like that affects everything. It seems like with the CT scanner, there's so many things that like I didn't even think about that need to be checked. Like examples from water bottles to batteries to shoes. Like otherwise, your feet would be getting wet when you walk in the rain. And then even to like a more serious level, like I can compare it, to a personal experience that I have a battery inside my under my skin. And thank
Right.
God there is, technology like this that can ensure the safety and use of those, medical products for that, say. Or like you said,
Yeah.
EV cars. I mean, gosh, no wonder why someone was just telling me about how their EV, they have an EV car and how their car insurance is a lot more expensive. Um, well, it's
Hmm.
probably because of the batteries, and hopefully that everyone's taking the necessary measures, like with the industrial CT scanner, like what you're showing, to prevent those things from happening. That is incredible.
Yeah. It's just the stakes in manufacturing quality are very, very high, and especially in areas like batteries and medical devices. It's a field where you absolutely have to deliver quality.
That is awesome. All right, is there any other examples or things you want to touch on about the software and how the CT scanner works?
Yeah, I can show you one last scan here to demo our latest configuration of the Neptune scanner. We offer the Neptune scanner in three configurations. There's kind of a base configuration, there's a high power configuration, and we've recently introduced a high resolution configuration. And this is a scan from our high resolution scanner. So this is a USB-C connector. It's an inexpensive, $10 Amazon Basics USB-C connector. And the detail in here is staggering. It is like such a beautiful object, and a really neat, illustration of how the world is just a much more complex place than you would expect. This is you know, a tiny like $10 device, and it has this, it has a PCB in it, almost microscopic. I mean, and then this cable is itself very complicated, has pins. It's like connected through. It has, an entire like tiny mechanism up here that helps the connector snap into the port on your computer. So um, anyway, just wanted to show you one of our micro focus high resolution scans as well. You can get, if you take a very, very small object and put it in our high resolution scanner, you can see the world in an entirely new way.
What a good analogy you made. Something that looks so simple on the outside, whether it's worldly or obviously in manufacturing, as we're talking, could be so detailed on the inside.
Yeah,
Wow,
absolutely.
that is incredible. Well, John, this has been awesome. I definitely want to close out this episode with letting all of our listeners know where they can find your information, where they can get in contact with you, who they should get in touch with, because I think people are going to be buzzing around
Yeah,
trying to get more information on this.
we would love to hear from your audience. You can learn more at lumafield.com. That's Lumafield.com. And if you want to learn more, you can contact us just info@lumafield.com.
Awesome, fantastic. John, thanks so much for being with us and everybody listening. Thanks for listening to this episode. Be sure to like and subscribe so you never miss an episode of Manufacturing Mavericks. Thanks.